Dr. Sehgal, we have a call coming in from DAV Durgapur. I'll interrupt you to take the call. DAV Durgapur, good afternoon. Ask your question, please.
Hello, madam. My question is, when a circular disc is rotating in a free space magnetic field region, then what will be the potential difference between the center and the rim of the circle, rim of the circular disc?
Now, when you are having a circular plate rotating in a magnetic field, then the rate of change of flux, that is what we will have to determine. And the rate of change of flux, that will be determined by, say, considering the plate at particular instant of time, at a particular inclination to the direction of the magnetic field, and then taking the derivative of that, we will get the rate of change of magnetic flux. And the rate of change of magnetic flux, that will give us the induced EMF. That is what you do in developing the theory of the generator. When you have a coil of any shape, any area, rotating in a magnetic field, then at a particular instant of time, when the normal to the plane of the coil makes an angle theta with the direction of the magnetic field, the flux linked is AB cos theta, and the rate of change of that will be given by AB sin theta. Therefore, that is what will determine the induced EMF. So, this is the standard theory of the AC generator. Okay, thank you.
We have a call coming in from DAV Jeend. DAV Jeend, good afternoon. Please ask your question.
Hello.
Hello,
morning,
yes.
everyone.
Good morning.
I am from Jeend.
Yes.
My question is in part 1, 6, page number 245.
Right.
There is a phasor diagram solution of series LCR circuit. In the diagram, the phasors VL and VC are taken in opposite directions. Therefore, the resultant is VC minus
Page
VL.
245.
In some other reference book, the resultant has been taken VL minus VC instead of VC minus VL. So please clear my doubt. What is the actual way of taking the resultant of VL and VC? My question is, in the same diagram, why the length of I is taken more than VR? Thank you.
Now, I am looking at these diagrams. What you are saying is that in this diagram, VC has been shown to have a greater magnitude than VL. Some of the other places you might find that VL is shown as having a greater magnitude than VC. Notice that the magnitude of VL and VC in a series LCR circuit will depend upon the current flowing in the two devices and the impedances of the two devices. Now you can have very well a situation in a series LCR circuit where the impedance of the capacitor is more than that of the inductor. You can equally well have a situation where the impedance of the inductor is more than that of the capacitor. Because they are in series, the current flowing through them is the same. Therefore, which of the two has a greater impedance, whether omega L is greater than 1 by omega C or whether omega L is less than 1 by omega C, depending upon that, one of the two will have a greater magnitude. So here in the diagram, as an illustration, as a particular case, it has been implicitly assumed that the impedance of the capacitor is more than that of the inductor. That is why VC has been shown to be of greater length than VL. Some other cases, one can very well assume that the impedance of the inductor is more than that of the capacitor. In that case, VL will be shown to have a greater length than VC. Both of them are equally correct. When you take the resultant amplitude, resultant impedance, you notice that we have to write R square plus omega L minus 1 by omega c whole square. So whether omega L is greater than 1 by omega c or whether less than that, the magnitude of this difference, that will remain the same. Plus or minus sign will come. But when we square them up, it will remain the same. Therefore, the resultant impedance will remain the same. But while drawing the phasor diagram, you have to assume that one of them is greater than the other. So one can assume either of the two possibilities.
We have a call coming in from DAV east of Kailash. DAV east of Kailash, you are connected with us. Please ask your question.
Hello.
Hello, ma'am. Ask your question.
Hello. Good morning, sir. Good morning, ma'am.
Good morning.
I have a problem in class 11. I have a problem in class 11 syllabus.
Yes.
Page 27 of first book, where we have the units and measurements. Example 2.10. So in this, we have to find out the errors in series and parallel combination. When we find out delta R in parallel combination, there they have given this formula delta R dash by R dash square is equal to delta R1 by R1 square plus delta R2 by R2 square by simple differentiation formula. Sir, but when we use this log formula like R is equal to R1 R2 upon R1 plus R2, when we take log and then differentiate, we get the formula delta R1 upon R1 plus delta R2 upon R2 plus delta in bracket R1 plus R2 upon R1 plus R2. So I have seen many books, wherever they have given this question, they have followed NCRT method. But if they have given some other question like focal length or convex length, there they have used this separate formula. The results from both are coming out to be very different. Sir, I want to know the answer, please.
Here what you are saying is that if you say calculate the logarithm and then you do the differentiation, then you get a different result. You have to remember that when you are writing 1 by r dash equal to 1 by r1 plus 1 by r2, and when you are taking the logarithm of 1 by r1 plus 1 by r2 will not be the logarithm of 1 by r1 plus logarithm of 1 by r2. So you have to take that care, and if you take that care and then carry out the differentiation, then there will be no difficulty. You will have to take that particular care, right?
Right, sir. My dear teachers, there is an information for you. The date sheet for class 12th has been put up on the DAVCMC website. Please refer to it. I will also read it out for your benefit. So friends, I also thank you for participating so enthusiastically in this teleconferencing session. Till then, goodbye and thank you very much.
ॐ द्यौः शान्तिरन्तरिक्षगं शान्तिः पृथिवी शान्तिरापः शान्तिरोषधयः शान्तिः वनस्पतयः शान्तिर्विश्वे देवाः शान्तिर्ब्रह्म शान्ति सर्वगं शान्ति शान्तिरेव शान्ति सामा शान्तिरेधि ॐ शान्ति शान्ति शान्तिः